All right, welcome to this brisk week 3. It's a little cold and wet outside. Not typical end of May weather for around here, that's for sure. Normally by now we're cooking to death. Um, Not like in some other parts of the world, but for around here it's usually pretty toasty. High 20s, low 30s, so it's a little off. All right, so this week we are going to be focusing on the basics of the select statement. Literally, the rest of the semester is all about the select statement for the most part. And today I'm just going to cover the absolute, uh, the simplest parts of it. Um, Last week I showed you guys a select star. For starters, I'm going to use a database called World. Later on, I might be using a different database. I provided a link in the announcements for it. Let me know if it doesn't work for you. Because I've had mixed results depending on reasons. So if it doesn't work, I'll regenerate a fresh one for you guys. So, all right. So the first one I'm using is World. Last week I showed you guys about use World. So, we're going to use World and use World. And it's not running. Fantastic. I got to go start MySQL. Let's try that again. Working much better now, as if it's turned on. Um, okay, so last week I did do select star for you guys, right? So um, I'll do select star from city. And what select star or select asterisk does is it returns every column and every row. So select star from city just says, give me absolutely everything you have in the city table. Fairly straightforward. Um, yeah. However, when you do select statements, you have to think about what you're running these select statements against. So for in most application environments, the database server usually is not sitting on the same machine as the web server or the application server. They're usually separated. Um, and if you have a very large table or a table with very large columns, um, where each row is significant, I know for most of you guys, you think, oh, 5K is not significant or 10K is not significant. It is. Um, because then suddenly if you pull back, I don't know, a million rows at 10K per row, you're pulling back 10 million K. And if you want to do some dividing on that, that's a gigabyte, if I remember it off the top of my head, I think. Um, I usually know this number off the top of my head. So if I do 10 million K divided by 1024, divided by 1024. Actually, no, I was wrong. It's 9.5 gigabytes. Okay, it's significant. So the problem you have is that the connection between your database server and your application web server is only so big. When you pull the plug in your sink at home and it's full of water, does the water just disappear? It takes a while, right? Because only so much can fit through that pipe. Same thing with the data. As much as you want to make it go fast, there's only so much I can fit through that pipe. Yes, in data centers, the pipes are really large and a lot can go through. But what happens if you got 10 people trying to do the same thing at the same time? So instead of moving 9 gigabytes, you're going to be moving 90 gigabytes all at the same time, right? So you got 10 people doing the same thing. The number just keeps getting bigger and bigger and bigger. And that means that there's network latency involved and it slows everything down and everybody else down. So what you tend to want to do is you want to retrieve the bare minimum of what you can. And I am just going to stop the recording first. This is my screen record software telling me I wasn't grabbing everything. All right. So what you want to do to fix that problem is you want to actually pull um, specific columns. And when you do specific columns, you are then retrieving just that little bit of data. So maybe the row is 10K or even 1K, but suddenly instead of pulling out 1K, you are going to pull back. For example, the first row would be 1, 2, 3, 4, 5, 6, 7, 8, and let's assume some separators in there, 10 bytes. Instead of 1,000 bytes, 1,024 bytes, I'm pulling back 10 bytes, which means now 1,000 rows occupies the same amount of space as the first row did originally, assuming a big data set. So normally when you write SQL, it's okay to do select star in a development environment as you're experimenting and figuring out the structure, but when you're actually writing proper SQL commands, just the required columns. It makes your code go faster, it spares the database torture, it spares the network torture, it removes latency, because, you know, if you can carry a box in your pocket, why would you have a wheelbarrow? So another way we can reduce how much gets pulled is there's a keyword called distinct. The country code from cities. City. Okay, so what distinct does, it says retrieve only the distinct rows being returned. So if you have two rows that are identical, it'll only ever return one. In this case, I'm asking, give me just the distinct country codes. Because in the database, we have, let me run this again, and let's go to the very last row. There's 4,079 rows, but that's each city in each country. If I run this, we have 232 rows because there's only 232 country codes in the database. It returns only the unique values. You have to be careful because the more columns you add, the more uniqueness you add. Because it doesn't operate per column. It operates on the entire set being returned. So if I were to take the one I had up here with whatever number of rows that was, and I slap a distinct in here, helps if you type it right. Look at that. We got 4,058 rows. Really? Let's check something. 4,079. So 79 minus 58, there's 21 duplicated rows where the city name and the country code is the same. Not necessarily shocking, because even in Canada, we'll have the same municipality, but in different provinces. This particular database doesn't really care about the provinces or the territories or the political divisions within the country, just city name, country code, duplicated. So it's literally returning just, it takes the entire row, so take Kabul, Afghanistan, and it takes that entire row for distinctness, not per column. So distinct is very useful, but just remember that the more things you add to the distinct, the more distinct each row becomes, and that means you get more and more data. If I were to change this and put in the ID, and we go to the end, we're back to 4,079 because every row is completely unique because of that ID. So just distinct is good, just be careful. Now we have alias. So I'm starting with the same query I've had so far. You guys are used to seeing this one already. However, what alias does, it allows you to rename things for the runtime of the query. It's not a permanent rename, you're just giving it a temporary name. So if I go rename this as city name, pay attention right here. I rename name to city name. Now, I know you guys have just started your programming journey. Some of you might have some experience already, but others do not. When you operate with code against a database, what often happens is each of the columns are returned. When you read a row of data, it a few ways you can pull it, but often one of the most common ways of it being pulled back is something known as an array. Array is basically a list of values, and it uses the column names as the identifiers for each section. What happens if you have the name showing, like something like name showing up twice? It's not going to generate a proper structure, probably get an error, et cetera, et cetera. So you can use aliases to rename pieces in your queries. At this point, not that important because you're only operating with one table. But when I start discussing joins and that kind of stuff, the aliases become much more important because sometimes you'll have the same column name in multiple tables. You might want to make them a little more distinct. Um, the alias is also good for making, what's the word I'm looking for? Um, things pretty. So you got to think back here. Okay, imagine yourself, you're as old as I am, and you're just at your current age going to college. And how did we hand in our SQL homework? Because I did take SQL in college. I'm not quite that old. I did take SQL in college, and the way we outputted our results is I learned with Oracle, and we could redirect the output of our queries to a line printer. So we type in our query, it shows up on the screen, it's correct. I could then take the output from that and redirect it to the line printer. But then the profs would say, it must be formatted in a certain way. So you can make things look pretty. And the other thing you have to take into account that way back in the day, often reports were sent to the line printer for distribution to the management. The management wasn't running SQL queries. They didn't have a nice tool with dashboards. Half the managers wouldn't even have computers in their office. They had people for that. And they'd just get a stack of paper dropped off in their office like once a week with all the reports for the week. And of course, they wouldn't want to see ugly things like city name and country code like this. They'd want it um, written like this. You have pretty names with spaces. Don't ever do that with programming code. If you're going to be reading this in Python or PHP or C Sharp, whatever, please don't ever do this. You're just going to make your life really, really hard. Different program languages treat spaces differently. You actually want to use the alias to take away spaces and make everything lowercase and, snake case and that fun stuff. But you can change the headers. So now imagine that I had this query and I directed it to the line printer, and then I would output with nice column headings. And the manager could kind of go, yes, I understand what these columns are because I'm too stupid to understand camel case. Um, I've been doing this for a long time. Trust me, there's a lot of stupid stuff. People ask for the dumbest things, just so you know. All right, so far I've discussed everything that happens before the from. From is pretty straightforward because it's where you grabbing the you want to select this value from this table. Hold it from here. Now this is where we start getting fancy. I have to explain to you guys the concept of something called a predicate. Often that terminology doesn't get used like it used to. However, when you search online every once in a while, they'll say, hey, the predicate you want for this is whatever. A predicate is an expression in SQL. And by the way, this also applies to all programming languages. Nobody that teaches Python calls it a predicate. It's basically any um, condition that evaluates to true or false. Did you guys even touch if statements yet? So if statements in Python or JavaScript is used for decision making. If condition, do this, else do this, or if you want to torture yourself, else if and then else. Okay. The condition that you do the if on inside those parentheses, or in Python without the parentheses, that's known as a predicate because you have something operator something and it will evaluate to true. It's just like math. And in SQL, it comes as part of the where clause. So if I go and grab, uh, let's go grab all the columns because I just want to see what I can play with. Okay. Um, Actually, you know what? Select star from city where, and then you give it a rule. So in this case, I'm actually going to say the ID is equal to 6. So it's going to basically run through the database table, looking at all the rows, and in each row it's going to say, is the ID equal to 6? Yes, no. Row 1, where the ID is 1, is going to go, is 1 equal to 6? No. Is 2 equal to 6? No. Eventually you'll hit row 6 and it goes, 6 is equal to 6. Yes. And we have one row that gets returned. This is a predicate. It's any expression that evaluates to true or false. Yes, no. The good news is there's no such thing as not yes, no. Okay, it either is or it is not. You'll have situations where you think it's saying maybe or I don't know. It's actually saying no. Basically, if it's not yes, it's no. So therefore, if your query is not doing what you expect it to do, it's probably because your predicate's wrong and you need to think about it. You also have to take into account that the computer is very, very literal. It will do exactly what you told it to do. And often what happens, because this is a very English-like language, sometimes English semantics that we use every day is actually the opposite of what we want in the computer. I'll demonstrate you that in a moment. However, we have some very common operators. The equal sign. By the way, in SQL, the equal sign is this equal. It's not a sign. People that come in from JavaScript or Java-like languages, I think Python's like that too. Double equals, triple equals. Yeah, no, one equal. Because this is literally saying select everything from city where the ID is equal to 1. And that's something else you'll learn about SQL. If you can read it like a sentence and it makes sense, it'll probably work. As long as you're fairly comfortable with your English. All right, so some of the operators we will see. The equal sign you've seen. Star from city where population greater than 1 million. Oh, gotta make sure I put my semicolons so I don't cause problems when you guys grab this file from me later. And now we have all our cities with a population of more than 1 million. Do you remember basic math operators when you're learning about algebra? Back in the day, greater than, less than, greater than or equal, less than or equal. Guess what? They're all here. Now, let me just grab this value here. Star from city where population is equal to this. Okay. Now, cool. I'm pulling out one row. I already showed you guys how that works. However, in SQL, you have two ways of writing not equal to this. When I went through school, we'd write it like this. And if we scroll down, you'll see that 35 is missing because it's literally everything but city that has that population. Now, we called it the diamond operator because, it's a diamond. Realistically, what it's saying is saying, select everything from city where the population is less than this and greater than this. Therefore, it's not going to be that, right? Written as one. Recently, by recently, I mean like in the last 15 years, I mean, you got to think SQL was written in the 70s originally. So, it's been around for a while. It's 51 years old. And it has changed over the years, and they've made things a little bit better. And somewhere along the way, some of the people writing the SQL standard said, you know what, we really should make those C-like programmers happy, and we'll give them this. Not equal in pretty much every C-like language. So that's Python, PHP, C, C++, Java, C Sharp. Pick your other C-like languages. That's all equal to not. This means not equal. The exclamation mark stands for not. Whatever. I don't care which way you write it. They're both valid. Um, just those of us of a certain vintage, I tend to go for this one because that's what my muscle memory says. They both do the same thing. They both run at the same speed. There is no difference. And it's actually exactly the same amount of time to type it. It's the same number of characters. So whatever makes you happy. Okay. So far, I've only shown you single value predicates. What happens if we want to check multiple things at once? We can do that. And we have special operators. And an or. Now, when you resolve a mathematical equation, what's the first thing you resolve? Nope, before that. The parentheses. They're not brackets. They're parentheses. Brackets are the square ones, just so you know. But like half the program perhaps will still call them brackets, but anyways, they're parentheses. I work with data. The right word for things is really important in my world. As it is today, I had a 45-minute meeting because I used the wrong word in something while I was asking for something at work, and they're like, "You can't have that." I go, "That's not what I'm asking for." He goes, "That's what you wrote." I'm like, "Oh." So that was 45 minutes. That could have been an email. Just saying. So it's important to use the right word. So they're parentheses. So we always resolve first using parentheses because in the SQL language, we have two keywords to let us have multiple predicates: and or. I put a pause in there because it sounds stupid saying and or. So and blank or. Those are two words we have, but there's an order they get operated on. And always gets resolved before or. I think it's the same in math. There's a certain order where, like even with BEDMAS, right, where it's multiplication, division. There you go. So let's just say I want to go start from city where the population is greater than 500,000 and the country code is equal to AFG. And apparently all we have is Kabul in Afghanistan. You will notice that my numbers don't have quotes, but my strings do. So if you have letters, and numbers, letters and special characters, that's considered a string. I don't know if they covered strings yet for you guys in any of your classes, but it's a string. Yeah. So not quite, but close enough for you guys to get it. A string is quoted. Um, Depending on your database server, the quote marks change. So by default, single quote marks are accepted everywhere. Double quote marks, because I could have written this with double quotes, but double quotes work in MySQL, MariaDB, Microsoft SQL Server, Postgres. They actually have different meaning. Double quotes actually mean something special. And Oracle, if I remember right, Oracle's picky about it too. Oracle depends where you put the double quotes. So not your mileage is not always guaranteed. So yes, the best practice is if you want to make your code portable, always use single quote marks. For the labs, as far as I know, the Saif will accept single quotes, double quotes. I don't think he cares. But for best practice, single quote marks. Just It's just better that way. Okay. All right. So this gets resolved first. Um, there's a few other ways we can run this. We could go this and population less than 1 million. And this gives us everything greater than 500,000 and less than 1 million. So far, I haven't needed parentheses because I'm only doing 2. Okay. If I were to rewrite this and go country code is equal to, let's go Argentina this time. And population is this, or, all right, let's go. I have no idea what this is going to do, so we're going to try it. Like I have my suspicion what it's going to do, but I have no idea what it's actually going to do. Okay, so it's giving me everything. Okay, but so what's happening is it's resolving this first, then it's doing the OR over here. And the problem is that this OR will give me absolutely everything less than that, right? Now, if I want to change the rules of how this works, so let's say Argentina population less than this. So now we've got everything less than this or the population greater than that. However, it's grabbing everything. If I want to have it be resolved properly, I could put this around parentheses. And now we have, it's always going to be less than 1 million. Let's go greater than 1 million. Okay. So now we have all the Argentinas or anybody who's got a population more than 1 million. The list got a lot smaller, 285 rows. You can play with your parentheses to your heart's content, and you say, I want to have this, and now we're getting a completely different set of data based on where I set my parentheses. Now, this is where you actually have to be a little bit careful. Not with the parentheses, with your multiple clauses. Because the human brain tends to want to understand things a certain way, and a lot of languages tend to wait. There's just some language. So I'm not talking programming. I'm talking like spoken language. Okay, let's say I want all the cities in Argentina and Afghanistan. So a lot of people, the first time they're learning SQL, they'd write it like this. And what do we get when we do this? We get nothing. Why? Yes. And are there any countries that have 2 country codes in the same spot? No. So this is where, people that are very fluent in English but don't know programming as much tend to get tripped up because they're going to go, well, they just asked me for everything in Argentina and Afghanistan, so why am I, when I say and, why am I not getting it? What the correct answer is or. So select everything from city where the country code is Argentina or the country code is Afghanistan. That will give you the combined set. So if at first you don't get what you expected, it might be your multiple clauses are throwing you for a loop. So just saying, just be careful with your ands and your ors. Okay. Time is it? Yeah, we're right on time. So the next one, which I did for you guys, which was this one here. Okay. So basically this is asking for the population that is between 500,000 to 1 million, non-inclusive. If I could rewrite this in such a way that's easier to read. which will give me the exact same result. Easier to read. You might want to slap that in parentheses because suddenly the keyword and is in there, but it's not actually being a, what's the word I'm looking for? Separating multiple predicates. It's actually participating in a single predicate. So, you may want to throw parentheses on that so you don't get confused on how it's being resolved. So yeah, you can do between. Now you've got to be aware when something is between, it means literally greater than the bottom value and less than the bigger value. Okay. Which leads me to the last operator, not. Before I run it, what's this going to give me? Anybody want to take a guess what it's going to give me? You might have to speak a little louder. Yes, but it will include the lowest value and the highest value. Right? So it's saying, basically it's saying, give me anything that's not in this set. And you can do same thing here. Actually I'll show you guys some not stuff later, but yeah, so if I go not between, you'll see that I've got numbers on both sides, but if we actually had 1,000,000 exact somewhere in there, it would not be it, it would be included. All right. Now, this one here is I want everything in these two countries. Now let's say we want to suddenly have 5 or 6 countries instead. Our code's going to start getting pretty tedious, right? A lot of OR statements, and then we have room for mistakes because we're adding things. We have a way of doing this, which is in. So if I were to go, let's add France and Spain. Pretty sure it's Spain. And if we scroll down, there's France. There's our France, not Spain, because I'm not getting Spain back. So JPN for Japan. Let's see, we got Japan. Yeah, okay, we got Japan. Good enough. All right. So the way this works is in this list of values, it's basically I'm doing where country code is equal to ARG, or country code is equal to AFG, or country code is equal to FRA, or it's equal to JPN. But we can give it as a nice common delimited list in this list. Later this semester, you'll learn that in is much more powerful than just a common delimited list. But for today, it's good enough. And of course, you can negate the in with not in this list. So it'll give me everything but those 4 countries. I'm actually going to put a comment in here for you guys. Everything but these 4, like that. All right, so far, most of the predicates have been fairly straightforward in concept. It's equal to this, it's greater than this, it's in this list. We have a combination. Super fancy. But the real power of database is when we suddenly start pattern matching. Pattern matching means you literally give it a pattern and it matches based on the rules you've given it in that pattern. In SQL, the universal pattern match command is like. So every database server offers the like command. Some others offer more powerful flavors of it, but they'll always give you like. And in my experience, like has covered like 95% to 98% of my needs. If it was something that didn't fit inside the like structure, I didn't even use the other commands. I went straight to regular expressions. Something you'll learn later in your programming career. Regular expressions make me want to cry every time I have to use them. It's like dark science. because I never remember what they are, so it takes me like forever to figure it out every time. Um, or I ask Copilot now, and it actually does a really good job. Um, so like is a pattern matching routine. You can use it to match pretty much patterns any which way you want. So if you go select star from city where name like. Now, a pattern will always be a string. You don't have a choice. And just say, you could be really lazy and you can go just type it all out, but why would you do that? Okay, so here's the one. I'm telling it where the pattern is like this, but I'm not actually doing any pattern matching. I'm giving it a complete value. So if you're going to do something like that, use an equal sign. It's more efficient. Although this database is so small and my laptop is fast enough that for all intents and purposes, there's no performance hit. But if you're operating on millions of rows of data, it's going to make a difference. So when we do like, we have two pattern matching capabilities. I'm going to just grab this line again. Let's say I want everything that starts with L. Oh, we have the percent sign. Okay, so the percent sign matches 0 or more characters. So it'll give you the letter L by itself as the first character. It'll give you any string that starts with L, where the first character is L. So whether it's only the letter L or L with 65 other letters, those will all evaluate to true. You can also put something after, like this. So suddenly this will give me all cities that starts with L and end in O. Doesn't care what's in the middle. Or it doesn't care how many letters there are in the middle. You can put the percent sign anywhere. So let's just say this is everything that starts with L. Starts with L. Um, this will give me everything that ends in O. Start with L and end with O. And this is where MySQL is a little special. It's not case sensitive. So it'll be lowercase l, uppercase L. It does not care. Other database servers, such as Postgres, is very case sensitive. So you may have to use, a slightly different technique to find everything that starts with L if you don't care about what flavor of L it is. And you can have multiple percent signs. So let's say I want to have L-O, and there's a T. All right, well, that was a bad example. With an E. There we go. So it's saying anything that starts with L, ends with O, that has a letter E anywhere else inside of it. It could be LE, because remember, percent sign is 0 or more times. Or it could be EO right at the end, which I don't think I have any examples, and then, or E anywhere else in the middle. So you can see that you can do some fairly powerful stuff with the pattern match. With some, as long as you can think up of how you'd want to break it down, cool. However, there is one other way we can do this. Or not one other way, there's one more thing we can do. We can be very picky about where characters are. So if I were to write, this, instead of percent signs, I use underscores. This will give me Laredo. What it's saying is the percent sign, so I mean the underscore means one and only one character. So it means that if you have an underscore, there must be something there. It doesn't care what it is, but there must be one character there. And if we're talking about trying to match a postal code, I have an example here that's commented out. I want everything that starts with K, ends with C, but I don't care what the number is. You could go K underscore C, and that will give you all the postal codes that start with K, 0 to 9, C. And then percent sign, because it doesn't care about the rest of the postal code. It's actually really fancy. You can actually do a fairly powerful set of combinations with this, depending on what you're trying to do. There's very few patterns that you can't match with this, unless you're trying to get really like weird. Match anything but ignore certain characters and stuff. That's outside of the needs of this. Um, so yeah, so with the like statement, you got multiple ways of writing it. Just mix match percent signs and underscores to meet what you're trying to target. Like the first example here is for phone numbers. Give me everything that starts with 613, but it must be of 10 digits. 044 if you want to call the UK. I don't know any other country. But 044 if you want to call the UK. But those numbers are going to be longer because they're not 10 digits long. Therefore, this would say 613, total 10 digits. It would give you everything in the Ottawa Valley. Okay. Um, the next one is I'm going to do is null, but I'm switching to another database. It's the one I linked in the announcement. You, you can just pull it down whenever. And I'm really lazy because I kept this query from before because I hate sitting in class trying to figure out which one I need to target. So this particular database has a table called roots. It's called FlightDB. It's actually real data. Some of you may have heard of a website called FlightAware. It lets you track flights. Like it shows you where the plane is on a map, but it's always delayed by 10 minutes for obvious reasons, right? You don't want to have the 100% accurate, where's this plane right now? It's probably not the best plan. However, at one point, they used to publish all the data, not the actual flight path, but they published airlines, airports, and the routes. So this airline would fly this plane from Paris to New York, and it would tell you, what the flight number was and all that fun stuff. It gave you all the information, and at one point, I actually extracted all that data and I put it in a database for students. So this is real data from like 10 years ago. They no longer provide this data. Again, wonder why. But so in this case, we have something called routes. Routes is plane takes off, plane lands. And street source airport means plane goes up, destination airport means plane comes down. Pretty simple concept. But you'll notice that some of these don't have a destination airport. So you'll see that it selects star from routes for destination airport is null. It doesn't say equal to null. It is null. Programming languages like Python and Java and JavaScript let you check if something is equal to null. That's because they're just trying to standardize how they do their operation checks. Database servers, on the other hand, realize that nulls actually have absence of information. Here's the problem. Can something be equal to the absence of value? No. Airport is It's impossible to be equal to null because null has no value, therefore it can never be equal to that. So the database developers decide, you know what, we're going to make this semantically sound, and we're going to go check if it is null, or you can go also say is not null. So let's get the opposite, where it ignores all the nulls. So it checks, see, field, are you null? Yes, no. Is it null? Yes, no. Is it not null? Yes, no. Because if something cannot be equal to null, it can also be, it's impossible for it to be not equal to null. Either it is null or it is not null. Otherwise, even an empty string, like just 2 quote marks, is a value. It's an empty string, not an absence of string. You can check to see if something's empty, but you can't check if something actually exists. Thus, they gave us an operator just for that purpose. It's called is. Okay, so now if I go, I'm going to go back to my world database for the last few items because I'm running out of time, big time. Wow, okay. Select star from city order by population. All right, smallest to biggest, order by. I can tell it to go the other way, descending, biggest to smallest, which apparently in this database is Mumbai. Go figure. We can actually go sort by multiple columns at once. So we can go select star from city, order by country code, comma population, descending, and I want the country code to be ascending. So this will get, it'll first sort by the country code and then sort by the population. So it'll go, I want all the country codes alphabetical, but then I want them sorted in biggest to smallest city. Cool. Now I am going to take this again and say, let's just say I want to know the biggest city. No questions asked, just want one. MySQL, Postgres provide a keyword called limit. And you go limit 1. Limit 1 means give me 1. Of course, you can combine most of what I've taught you already, which is here I can put in where country code in CAD USA. And apparently New York's the biggest city in North America when this database was created. So this is showing you some of everything I've done so far tonight. But what's really cool, and it's the last one, let's say you don't want to know the biggest city. You want to know the second biggest city, but you don't want to return 2 rows, right? Because so you could go return limit 2, congrats, LA is the second biggest city in this database. But let's say all I want is the second biggest city. What I can do is go limit 1, offset 1. So this is saying is I want 1 row back. Offset means skip. So if you go offset 1 means skip 1, show me the next one. Then you can go offset 2, offset 3. So just, man, really tight time. You know when you go on a website and they have pages, you go, it shows you 20 rows, you hit next. Then it shows you 20 rows, you get next. Some of you may remember websites that are a little bit older like that. What they're doing is they're going, select whatever that is from the table, limit 20, offset 0. Then you hit next page, go limit 20, offset 20. Limit 20, offset 40. And they're only retrieving those 20 rows. They're not retrieving a million rows and then, looping through them to find those 20. It literally says, I want those 20, offset to the next. Limit these 20, offset to the next. Different database servers do this differently. Microsoft SQL Server has a command called top, top 10. That gives you the first 10. Oracle's absolutely stupid. I haven't even taught you guys the techniques to be able to do the Oracle version of this, but you have to nest queries inside each other to make it work in Oracle. Postgres, IBM DB2, MySQL, we do it the best of them all, which is limit, offset, magic. And that is the end of my sample file for you guys. So yeah, you should have everything you need to do your labs with this today.